here we go with lesson 7.5, factoring linear expressions. This is your last section of chapter 7. So to factor, first off, we want to talk about finding the GCF of each pair of monomials. I know you guys like to use that tic-tac-toe method. So we fill that in. So in our first example, we want to find the GCF of 4x and 12x. So we have 4x and we have 12x. Okay, well, if I look at my numbers first, so 4 and 12, what could I factor out of 4 and 12? Well, I know that I can factor a 4 out. Some of you might have done 2 and then another 2. But for me, I'm just going to start with the 4. So 4x divided by 4, that leaves me with an x. 2x, or 12x, sorry, divided by 4 leaves me with a 3x. So I have a 1 and a 3. There are no more numbers that I can take out. So now if I look at my variables, I notice that there's an x in both of them. So I can remove an x. X divided by x is 1. 3x divided by x leaves us with 3. So then my GCF, just like you guys told me previously, you're going to multiply what's out here. So 4 times x, my GCF would be 4x. Kind of squeeze it in down there. Okay, for our second one, we had 18a and 20ab. So same idea. We're going to make that tic-tac-toe board. We have 18a and I have 20ab. So again, if I look at my coefficients, so what can I divide out of an 18 and a 20? Well, they're both even, so let's start with a 2 and see what happens. So 18a divided by 2 leaves us with 9a. 20ab divided by 2 leaves us with 10ab. Okay, I now have a 9 and I have a 10. There's nothing other than 1 that divides out of those. So now let's take a look at our variables. We have an a, we have an ab. Well, I see that they both have an a in common. So divide out an a. 9a divided by 9, or divided by a, leaves us with a 9. 10ab divided by a leaves me with a 10 and a b. Notice my a's factored out of each of them. So again, multiply what's out here. 2 times a leaves me with a GCF of 2a. Okay, so now how are we going to apply this? You can use the distributive property and the work backward strategy to express an algebraic expression as a product of its factors. An algebraic expression is in factored form when it is expressed as a product of its factors. Okay, so factor each expression. I have 3x plus 9. When I factor, I want to find my GCF. So if I have 3x and 9, well, if I look at my coefficients, I have a 3 and a 9. So 3 divides into both of those. 3x divided by 3 leaves me with x. 9 divided by 3 leaves me with 3. There's nothing that I can factor out of an x and a 3. So my GCF is 3. My GCF goes to the outside. GCF goes to the outside. Then what's left inside? Notice they are both positive. You do not multiply them. This is my inside. Again, do not multiply. Since they are both positive, we are going to be adding them. Notice, started with plus, ended with plus. So 3 times x plus 3. And if you're not sure if you're right, you can check it by distributing. So 3 times x gives us 3x. 3 times 3 gives us positive 9. Takes you back to the beginning of 3x plus 9. Okay, part B, 12x plus 7. If I made a quick tic-tac-toe board, I have 12x, I have 7. Well, the only thing that goes into 12 and 7 is 1. I notice that my x, or my 12 has an x, but my 7 does not. So there is nothing that can be factored. So our answer here would be that it is already in factored form. It cannot be factored. It's already in factored form. Write this you guys can actually read it real quick. It's an E, then a D, factored form. All right, one more problem. The garden at the right has a total area of 15x plus 18 square feet. Find the possible dimensions of the garden. So area equals 15x plus 18, because this section is 15x, this section is 18, so total we have 15x plus 18. Well, you know that area is length times width for a rectangle, so I'm looking for two things multiplied together that would give me 15x plus 18. So we are going to factor it, which means I want to find my GCF. So 15x, 18, let's make our board. So what can I factor out of 15x and 18? Well, I can factor a 3. 15x divided by 3 leaves me with 5x. 18 divided by 3 leaves me with 6. Nothing else factors into 5 and 6. 5 has an x, 6 does not. So this is one of my factors, and then this is one of my factors. So possible dimensions of the garden, one dimension would be 3. The other dimension would be 5x plus 6. So 3 by 5x plus 6. So if you want, you can write it over here. This side is 3, and this side is 5x plus 6. All right, there's your last lesson.